All right, welcome to lecture two, or sorry, video two. We'll be talking about line plots in Matplotlib and Seaborn. As you guys remember, Matplotlib and Seaborn are going to be our two main libraries that I imported up here for data visualization. And first off, we'll get started talking about line plots. So cool. All right, so line plots are usually really useful for the visualization of two numerical values, either continuous or discrete. So if we go to our database and we try to figure out what numerical values do we have that we think would be strongly correlated um, to an increase in revenue. So if we go back here and we see our numerical value, so budget is definitely one of them. Another one is popularity, and release month and release year, again, while they are numerical values, I think in this context we would treat them more as categorical variables, because again, as you remember, categorical variables help describe the description, or it's the description of something related to our data set, if that makes sense. So we can consider both month and year a categorical variable because we can like group all the movies that were released in January, February, March, or all the movies that are released in 1970, 2000. So those we can consider as categorical variables. But I would say that release year could also be a numerical variable in the sense that we can plot something against the year it was released to see if there's any correlation between the two. Just because it is continuous and it keeps on going until time stops essentially. Whereas month, there's only 12 months. So release year and release month are considered categorical variables, but year can also be considered numerical. And release day, I wouldn't say, again, that's also more like the month where you can only go up to 30, 31 days. So that would also be a categorical variable. So the main ones we have are the budget and the popularity. So let's actually get started making a line plot of a movie's budget against its revenue generated with that budget. So we'll get started with Matplotlib. So in Matplotlib, the way we represent line plots is through the code plt.plot, and plt.plot will take in an arbitrary number of values or arguments, but in this case, because we're only measuring the relationship between budget and revenue, it'll only take in two values, budget as our x and revenue as our y. So the way we want to represent this in Matplotlib is we always want to index into our columns essentially. So we would have our table revised movies. So let me just write the general format for this. So we would have a table name and we would index into our column by specifying the column name. And then we would have our y argument, which is table name again, and we would index into column name y. Let me actually just specify what's our y and what's our x. So I'll just say column name x here. Okay, so that's essentially what the code is going to look like for Matplotlib. So if we wanted to visualize the relationship between these two, all we have to do is go plt.plot and then revise movies, and our x column will be budget, and then our y column will be revenue. So the graph that we get looks like this. So this is not really a very descriptive graph at all, and the reason is that when you try using a line plot for a visualization, a line plot works best with only a few number of data points. And in this case, because our table or our data set has over 3,000 rows, it's going to be really efficient because what Matplotlib is trying to do is essentially it's trying to connect every single line to another line. And that's, again, really going to be really inefficient just because we have so many lines out there and so many data points that we're not going to get really anything of really good substance to judge a relationship from. But say we wanted to, this isn't a really good visualization, but say we wanted to add a line to our line plot. So we'll get. Oh, sorry. Before that, let me just talk about that. In every good visualization, we're gonna want to have our x-axis labeled and our y-axis labeled. So the code that we can write to label our x-axis is simply x.label, and you would pass in um, literally what you want it to be labeled, and same with the y-axis. We would want this to be labeled revenue, and then same with the title. All we have to do is plt.title and we'll label that budget versus revenue. And that's really all we have to do. Sorry, I misspelled that. And we get a great visualization. But say we wanted to add a second line to our line plot. Because again, this is just one big continuous line trying to connect every point to itself. So say we wanted to add a second line. Plt.plot can actually take in a third argument um, to help us accomplish that. Because plt.plot is actually really um, it's really it's not a great tool for us to draw line plots as compared to our counterpart, which is Seaborn, which is SNS.line plot. I'll talk about that later. But if we wanted to add a second line to this graph, we would have to, again, make sure that we're not plotting too many points at once because, as I mentioned, line plots aren't really good with that many points. So say we say we uh, say we go back to our data set and now say we want to let's pivot a little bit away from revenue. I just want to show you guys a quick demonstration for the purpose of this third argument. But say we wanted to figure out whether certain months had a increased had a abnormally high movie revenue. For example, say we hypothesize that January or February, a lot more movies were a lot more revenue was generated for movies in January, February versus towards the end of the month. Say that was our hypothesis. And again, because I told you that revenue, release month, release year, release day can all be considered categorical variables and numerical variables, we can try graphing our release month versus our revenue generated from that month. So let's try doing that. I actually made a table in a different Jupyter notebook, so I'm just going to copy that over. And basically what I did is I grouped this original table by the release month. So there's 12 months, obviously, so there's 12 different columns in my new table, which is called NSM. I grouped it by release month, and I added two columns. One of them is the average popularity over the entire year for all the movies in our data set. So for all 3,000 movies, what was the average popularity from January to December? And this first column, just popularity, is the average popularity of all the movies generated in that month. So all the movies in January, the average popularity for that is 6.837, for example. So say we wanted to graph two line plots in our next graph. One line plot was the relationship between the release month and the popularity of that specific month of the movies. And our second line plot is just a straight line of the relationship between release month and the average popularity over the entire year. So that obviously just going to be a straight horizontal line. And our second one is going to be a it's going to vary a little bit depending on which month, as you guys can see from this first column, because obviously revenues generated in different months are not equal. And this will really help us be able to tell whether some months had an unequal level of revenue generated by movies produced in those months. So let's actually try that out right now. So if we wanted to pass in a third argument, all we had to do was have the same original plt.plot, and we can just write NSM and then index into our first argument, which is the x-axis, and our second argument this time will be popularity, and then our third argument will be average popularity. So essentially, this is creating two line plots, one corresponding to the relationship between the first and second argument, and the second corresponding to the relationship between the first and the third argument. So let's graph that here, and then, as always with any other good graph, we would label our axes. So when we do that, sorry, actually, okay. So what we get essentially is this graph over here, and this graph tells us that actually not movies that generated the most revenue were actually more prevalent in June and July rather than uh, earlier in the year, like January and February. January and February actually had lower, some of the most lowest movie revenues, while movies that released in the summer had some of the highest. So a line plot would be really useful for this again, because we can consider both month and popularity essentially as a numerical variable. But um, what causes this difference? Obviously, this difference is huge, but we want to know, why are movies released in June and July so much more, popular actually, um, than movies that were released, before that? And the reason is, I mean, we really can't tell. It could be that the metrics of popularity measurement was different throughout the entire year for movies. So maybe they had a different scale of measurement in June and July versus, like, January. Or something else that could be a big thing is that movies that are released in the summer are generally more popular because students and um, college students are all out in the summer from school, so maybe they might have more time to watch a movie, and therefore would that would maybe cause it to be more strongly correlated with popularity. Who knows? So uh, to really figure out the essence of this problem, we need to run a lot more statistical tests, which are again beyond the scope of this class. So essentially, all I'm trying to show is that that there are in fact more movies that are popular in June and July than usual. Okay, so now let's move on to Seaborn, because Seaborn is also a our second data visualization library that we're going to see is actually a lot more useful for us when it comes to line plots. So Seaborn, the function to create a line plot in Seaborn is going to be very similar to before, but this time it's going to be plt dot, sorry, not plt, sns dot line plot, and that's going to take in our x and then our y arguments. That's really all it's going to be. And there's again a lot more optional arguments that we can have here, which I'll talk about in just a few moments. So going back to our revenue versus budget graph, like in this graph in Matplotlib, we really couldn't tell anything in the relationship. But say we wanted to graph it in Seaborn. This is actually a lot more efficient, and I'll tell you why in just a moment. So let's just graph this real quick. Just copy this to save some time, and then change that to revenue. And then we will want to title our graph revenue versus budget. So when we graph this, actually, Seaborn is really smart because it automatically labels the X and Y columns for us. And as we can see from this graph, why is this graph so much more linear, I guess you can say, than the one demonstrated in Matplotlib? It's the exact same data points, data values, but this one obviously shows a very clear relationship. And the reason is because in Seaborn, if you see from these, like this dark shaded, not this dark line, this is basically the average of all the different movies, average revenue for all the different movies produced with that budget. And the shaded area over here is the variability in all the movie revenues at that budget. So take, for example, 6 movies were produced with a budget of 1.9 times 10 to the 8th. Okay, so the average revenue for that movie, demonstrated by Seaborn, of all 6 different movies, the average revenue is actually this dark line right here, which is right about there. And this big shaded area is basically the variability of all the movies at this particular budget. So because we do have 6 different budgets, say we wanted to add another data point to our set, which had a exact same budget of around 1.9 times 10 to the 8th, Seaborn basically tells us that that movie is very likely to have a revenue that is contained within this shaded area over here. So that's going to be really cool for us later on when we work on statistical models and such. But again, Seaborn is a lot more efficient at telling us about any possible relationships again, because it does not connect every single line at every single point to itself. It only connects the average points at that value. Okay, so another really cool feature about Seaborn is that instead of writing this really redundant line where we specify that we're indexing into the columns twice, instead we can just have an optional beginning argument called data, which just specifies our table name. And then we can just specify our X and Y columns as such without having to index into them. And that's going to make our life a lot more easier when we have a lot more arguments in our graph. So as you can see, this graph outputs the same exact thing as our original graph, which is really cool, and it keeps the labels and everything. So that's going to be really important to consider later on. Okay. So now that we've established that there is a positive correlation between budget and revenue, say we wanted to take into account something else, like runtime, as I mentioned in our data set. So say we wanted to think, is there a correlation between the movie's runtime and its revenue? And say we hypothesize that movies that tended to have a longer runtime or had a generated actually more revenue. Say that was our hypothesis. So we can test that really quickly by just um, writing the code for this. Data is equal to revise movies, and our x will be runtime, while our y will be revenue. And as you can see, from our graph, there's not really a strong relationship that we can get from this visualization. Besides for the fact that movies with an average runtime of about 2 hours to 3 hours tended to have the highest revenue, and that does make sense because movies that are shorter, or that are how do I say this, like that have average run times, I guess, are more convenient for an audience. No one wants to sit through a really long movie, or does no one want to sit through a really short movie. But besides for that, this doesn't really give us any other relationship, any other useful relationship. But so yeah, runtime probably isn't uh, one of the best variables to correlate revenue with. Okay, so I want to talk about another additional argument that Seaborn can take in its line plots that are really useful, and this is a hue argument. So say we wanted to add a categorical variable to our graph. And what I mean by that, say that we wanted to compare budget and revenue for movies that belong to a collection and movies that didn't. So would movies that belong to a collection have a higher distribution of budget versus revenue versus movies that didn't? And in this case, we would be literally extracting two line plots in a single graph. One line plot will correspond to the movies that did belong to a collection, and the other line plot will correspond to the movies that don't belong to a collection. So all we have to do is just repeat the same thing, but this time we're going to add a optional hue argument at the end in just a second. Hue is belongs to collection. And we're going to see that once we graph this, actually, there is a little bit of a difference between movies that belong to collections and that don't. So the blue line is represented by movies that do belong to collection and vice versa, and that's really cool because Seaborn actually also gives us a key at the top left-hand corner, which tells us the difference between the two. But again, this difference in the graph appears very slight. We really have no way to measure this just from this graph alone. But because belongs to collection is a categorical variable, it'll be useful for us later on when we talk about bar plots and such. So for now, we really can't demonstrate any huge relationship besides the fact that, movies that do belong to collections do tend to generate a little bit more of a revenue than those that don't. Okay. So let's say we can find. So let's try to find any more categorical relationships within our data using a line plot. So obviously we would have to use our hue argument again because we're looking at categorical variables. So say we wanted to look at the categorical variable original language, and say we hypothesized that movies that were produced in English tended to have a higher revenue than movies that weren't, for example, because English is known as the world language. So say we drew the same exact graph of budget versus revenue, but this time we wanted to look at the categorical variable belongs to collection, or sorry, original language. Okay, I think I forgot Okay, cool. So when we draw this graph on Seaborn, we can see that there is a pretty big difference from the pink line and all the other colored lines. And the pink line is represented by English. So we can tell that movies that were produced in English tended to have a much higher budget than movies that were produced in other languages. But that's only true, and actually that's only true for English, that English movies had a higher budget. But English movies also somewhat had a higher revenue for those budgets. And what I mean by that is if we take a look at this budget, 1 times 10 to the eighth, we can see that movies produced in English both had a higher budget and a higher revenue. However, we can't see any other of these lines. A lot of these other movies that were produced in different languages had a maximum budget of 1.10 to the eighth dollars, and that's really key in analyzing our graph. That say we just wanted to look at the range between $0 and 1 to the times 10 to the eighth, we can't again really tell any meaningful relationship because that area is just so cluttered with so many different lines and languages that it's really useless to us for now. Until we can look at a bar plot, which will help us distinguish these categorical variables a little bit better. But for now, we can tell that yes, English movies did receive a higher budget, and with those higher budgets, they did receive a higher revenue. Okay, so another really cool argument that I want to talk about really quickly before ending the discussion on Seaborn is the argument palette. And basically, palette helps us determine what colors we want our graph to be. So right now we have pink, blue, green, orange, a lot of different colors like in the rainbow. Now, say I was presenting this visualization to a audience that was colorblind, and they couldn't tell the difference between all these different graphs. They could only see that there's one big line that extends out, but I don't know what language that is. So if I wanted to tell the specific difference between all the languages, if I was a colorblind person, I could pass in the argument colorblind to palette actually. There's a lot more different values that this palette argument can take, and that's included in the Seaborn documentation. But I just wanted to show you one um, out of curiosity that it's pretty cool that Seaborn will actually change these colors to make it work for someone that is in fact colorblind. So that's really fascinating. Okay, anyways, so that was our discussion about line plots. We talked about um, most of the numerical values in our data set. But now, before we wrap up, I just want to conclude with talking about all the different variables that we did see have a strong correlation with revenue. So we saw, for one, that budget did have a very linear correlation. But let me just change that. Okay, so we saw budget did have a pretty linear correlation. Now, when we looked at these categorical variables, belongs to collection and original language, it was a little bit hard to tell the difference for these two categorical variables because we were using a line plot. But we can definitely see that there is somewhat of a difference between movies that belong to a collection, those that didn't, and English movies along with the rest of the world. So I think that we can safely assume that belongs to collection and original language are in fact good correlated with revenue, but we don't know how strong this correlation is. So we're going to want to use bar plots in the next video to determine how strong this really is. Cool. Thank you for tuning into this video.